So let's begin implementing normalize function. So we have defined the prototype already. So let's put it on the very top, void fraction normalize given numerator and denominator. So here normalize, what you want to do is as follows. Normalize means fraction by first when moving sign. If it's a negative number, if a numerator or a denominator could be a negative, then put the sign to numerator only, so that later we do some arithmetic, it's convenient that denominator is always positive. And then second step is ensuring numerator and the denominator have no common divisors. So as we find the greatest common divisor, we can just divide and reduce the fraction accordingly there. So normalize is by doing those two steps. So let's take care of sign first. So integer sign is positive, that if numerator is negative, then what you want to do is sign is negative, and then numerator is we can change negative numerator. Okay, so make a numerator positive value, but sign flag is negative now. And if the denominator is negative, then we just flip the current sign. Sign is a negative sign. If currently sign is positive, it becomes negative, negative becomes a positive, and then denominator becomes a negative of a denominator. So by doing those two steps, we ensure the first one, sign is always on the numerator side. At this moment, actually, we need to assert that denominator should not be negative or zero. I mean, it's a zero. If it's a zero, there is it's not divisible. So make sure that denominator is not non-zero, and we need to include C assert library there. So now let's find the greatest common divisor. So let's have a greatest common divisor is 1. It's always it's a common divisor, and then let's find the greatest one. If numerator is a positive, then greatest common divisor is, we are going to define greatest common divisor function given numerator and denominator there. We are going to define function later, but by calling the function, we find the greatest common divisor, which is D. Then top becomes a sign, whatever sign we have so far, and then top divided by greatest common divisor. That's not top, it's a numerator. Numerator is a sign times a numerator divided by greatest common divisor. And then denominator is a denominator divided by greatest common divisor. Okay. So if numerator is not positive, which means it is a 0, then greatest common divisor should be 1, so we don't have to do anything at all though, but just in general case. So this is the idea how to reduce this. So now what is left over is greatest common divisor function. Actually, you can do a Google search to find the such algorithm, and then one of the most famous one is Euclid's greatest common divisor algorithm. So let me just use it. So it's integer GCD given two integers, a greatest common divisor, we are going to find that. So let's have another function for that. Fraction, greatest common divisor, integer n and integer m. Then based on Euclid's algorithm, we can implement as follows. First, assert that n is a positive, and then m is also positive. Otherwise, the algorithm does not work. So algorithm is, you can do a Google search to find this algorithm, not equal to m. What you do is if n is smaller than m, then what you do is m minus n, else n is n minus m. Just loop that and then return n. That is how to find the greatest common divisor. So if we provide a denominator and numerator to create the fraction object, then normalize is called, and then we ensure that sign is always on the numerator, and then it is reduced by greatest common divisor. So let's test this code so far. So we need to create make a file. Goal is a.out. If you are using Windows, it's a.exe. Main.o is needed. A fraction.o is needed with a debug symbol there. Then fraction.o is achieved by compiling fraction.cpp, which includes fraction.h minus g minus c fraction.cpp. And main.o, we get it as by compiling main.cpp, where fraction.h is included. Debug symbol, compile only main.cpp. That's what we do. Let me open a terminal and main. Let's see something like this. Constructor default one by providing numerator only, or by providing numerator and denominator, and then we go through normalization and the like. So let's put a breakpoint here and compile and start debug. F1, 2, 3 numerator, denominator. At this moment F1 and F2 are set. So 0, 1, 3, 1 is there for F3. If I do step over 1 and 2, normalization is correctly done.